Our next presenter is Larry Goldberg, and Larry is not only well known as an inventor, or co-inventor of the decision model, and one probably of founder of decision management movement in general. Larry, one of the most known people who actually developed the system, who actually works with customers, and not with little customer, small problems, but probably with, he is probably chief architect of the largest decision management application used by largest financial institutions in the world. So his experience comes not only from theoretical point of view, but also from real world perspective. So, Larry?
Thank you, Jim. Well, hi, everybody. So, going back to 2009, Barbara van Halle and I, we published a book called The Decision Model, and this was a model that we had invented. It's in use now in a very large number of many large financial institutions, as Jacob alluded to, very successfully in production, in large-scale applications, including core banking systems for several of the largest banking companies in the world, large mortgage institutions, and a fair number of healthcare companies, and very successfully enabling the business to manage their body of logic, their logic assets, in a tool that we now call Sapiens Decision. This tool was built in 2010. The tool actually has the ability to render its models in either DMN or TDM format or notation. And we are barreling down the road towards adoption, as Bruce pointed out, of DMN in a modeling tool. And we're looking very seriously at the conformance levels, and as Bruce said, considering conformance level 3. So that's the background. What I'm going to talk to you today is not about decision modeling per se, but about some of the implications of implementing models in the real world, and specifically around the problem of implementing production assets, production decisions, and connecting it to data. Turns out that that's the long pole in the tent. Turns out that we've been extraordinarily successful in engaging the business in building their assets. We've been extraordinarily successful in generating from those assets executable code in the form of services, microservices, if you like, APIs. The long pole in the tent has been integrating that into the data environments that we've been exposed to. And a client of ours about 3 years ago said to us, but why don't you just model the data for us? Why don't you have the business model the data for us? We said, well, we do. We have this glossary, and they model it in the glossary. And they said, well, that's really not enough. Let's model the integration. So that's what I'm going to talk about today. That's where this journey has taken us to. We now have a module, a component of our suite, which we call Decision Info Hub. And I'm going to talk about the journey that we took, or what we ended up with in this Info Hub environment. And what we've discovered is that modeling decisions, whether DMN or TDM, is a very powerful paradigm in the building of solutions, in the building of applications. We talk about application development. When you look at an application from a perspective of modeling the logic as decisions, modeling decisions, it changes the architecture, it changes the approach. It really does revolutionize the thinking about what an application may look like. And it definitely dramatically shortens the cycle of development very substantially. And we've seen development cost and time drop dramatically and quality increase dramatically. The long pole in the tent, as I've said, is this problem of integration. So we get these applications very rapidly rolled out. We get these solutions very rapidly built. We get these the business engaged in designing their requirements, engaged in actually generating the code from their requirements. What we have a great deal of difficulty in is this integration piece with the data. And we always believed that if we were very rigorous about the glossary, and if we incorporated the glossary into the building of the model, as is done in DMN and as we do in PDM, we would solve the problem because we would provide a solid basis for the data guys to integrate into the glossary, or we would actually discover the requirements in the glossary that were not supported by the data. Well, it ends up that we get these assets built very rapidly, we get these assets built very exactly, and we get these assets built to the business's requirements. But then we start this long trek down the path of integrating to the data. So in response to our clients' needs, we have developed this notion of the business logical unit. So what is a business logical unit? It's really the name we give to the model of the information inputs and outputs of a decision model. Really from the integration perspective, once you have a decision model for your as representing your logic requirements, really if you just look at the inputs, the variables as they're called in DMN, that's the model you need for your data. So we said, well, then let's model that. Let's use that as our basis, as the basis of what we're going to build in our integration. So we're able to extend the model-based paradigm into the data integration implementation of decision models. And the business logical model is implemented in a tool that we call this Decision Info Hub. What has happened, though, is that in thinking about the data as a business logical unit and in implementing this business logical unit, we have generated some very virtuous results. Turns out that not only can this improve dramatically the speed to market, or the speed to completion, speed to integration, but also it has some huge, some very, very important results in terms of performance in the actual decision execution. I'm going to talk to that in a minute. It's improved our data governance dramatically, and there are some other virtuous results that we earn from this from looking at this business logical unit as a model for integration. So if you think about your classic data environment, and you think about your data scattered across multiple units like CRM or billing, each system is independent, each contains models of data that relate to that particular application. Very often there is no gold standard. We find duplication of data or replication of data across these systems very difficult to integrate into that environment. When we have unstructured big data, we have other problems. The data, there's no business logic in the storage of the data. Data access from one entity requires lookup across massive amounts of data. The business logic unit, if we actually not only organize our data by the business logic unit, but if we store it by the business logic unit, then we get some real benefits. So distributed storage on demand, we can actually deal with in memory one business logic unit at a time. data access for one instance is a core feature, and it aligns with our glossary very closely and gives the business view of the data required for a given decision. So, if we think about the business logical unit, one of the ideas that appealed to us, that came to us in this thinking and in this approach, is that what happens if we store each instance of that business logic unit as a complete database in whole? We include all its metadata, we include all its indexes, and we store that not as an instance within a database, but as a database in and of itself. And why would we do that? Well, I'll get to that in a minute, but let's just define the business logic unit for a second. So it's a generic word used to encapsulate the concept. The actual business logic unit type is a specific type of a logic unit representing business-oriented data, so policy renewal, product pricing, patient claim eligibility. It would represent all the data that we would need for the decision related to business claim eligibility or product pricing or loan eligibility. And we configure those within our studio, within this tool that we've created to support this business logical unit called the Decision Information Studio. And an instance of a business logic unit is the actual database that one instance of that type represents. So policy number, product number, or patient number, and they're a micro database on the DI server. So if we store it as a micro database, we can store all the information about a patient claim eligibility, or the inputs for the patient claim eligibility for a specific patient number or a specific product, and so on. So there is a reason I'm driving towards this business logic unit, but let's just look at what it may look like for a second. This is the policy renewal example that we give in our book and we use frequently. This is what a policy renewal decision model may look like. And these are the inputs for each of these decisions. These inputs constitute actually, if you take all these inputs together, they constitute the input component of the business logic unit. The output, the policy renewal method, constitutes the output component. And these components of the business logic unit would be some of the source tables that together make up all the data that we need. So these would be representative of data elements, tables or entities, attributes in some external tables in some database somewhere, and that we have identified as being source for the entities for the fact types that we need in the input table. And so this constitutes the business logical unit. And if we store this as a database, as a complete database, then each time we need an input into our decision, all we have to do is populate these tables, query these tables, populate this value, do whatever ETL we need to do, because typically that's one of the problems that we face. And then we're ready to execute this decision. When we execute this decision, we can populate this output. And this together forms the basis for all the analytics that we're going to do on these decisions in the future, and gives us a platform for improving our decisions and understanding what is happening in our decisions. Now, what is the value of this? This is just a TDM representation of that. Well, so let me also say that from an implementation point of view, what we do is we keep this logic unit in memory for the purpose of execution. And that's all we have to keep in memory. So for that reason, we can keep a very small amount of data in memory when we need to execute an extremely small amount of data in memory. We can compress it if necessary, and we can distribute this data across a very large number of servers, and we can use all the parallel and clustering and distribution that's available to us. And so, because we're using very small amounts of data at any one time, our performance remains extremely high, as we've seen, as we'll see in the results of our performance. So, once we're able to do this, we're able to give the business a model of what their data would need to look like, and what their mapping, and what their, and they would use ETL tools, and we built those into our product to be able to build this relationship and do this mapping. So we provide the ability to synchronize into this logical unit on an on-demand basis, or on an event basis, or an always sync basis, which may be a combination of the above, so that when they're actually executing, we're able to provide the data on an as-needed basis to improve performance. And one of the advantages that we derive from this capability, particularly when we want to distribute this data across, say, the internet, on the web, is a very high level of security, because we're able to encrypt each logical unit instance separately. So we're able to encrypt the master, each logical unit type separately, and then each logical unit instance separately, which means that to actually break into this data, you'd have to break all three keys, and then when you've done that, congratulations, you've got one instance of data from what you've done. You're actually going to have to break each instance to actually break the key of all the data, underlying data in the database. So we can with a great deal of comfort distribute this database and know that our data is going to be very secure. So this is what we ended up with in terms of architecture. So the architecture of the tool, this is the tool here, is it has an ETL layer for connecting to source systems, ETL layer for source data. We have connectors to a wide range of source systems. Much of this is made up of open source available componentry. Our actual distributed database, we're using Cassandra. And then in InfoHub itself, the actual proprietary components are the LU Storage Manager, the encryption and authentication engine, the processing engine, and the smart data controller to ensure the flow of data through the tool. And then we have a studio component that actually the business user will use to design their models, and then actually, once they've designed their models, they will actually publish them to the server. So that's how the tool works. The tool enables us to make REST or SOAP services available for external applications to call the engine. The engine will actually call the tool will actually call the rules engine. We use a wide range of different rules engines, including our own, but third-party rules engines to actually execute the models that the decision models that we create. And this gives us really what amounts to a business view and a business management tool, which looks something like our decision management tool, allowing business to model and IT to actually implement and deploy the models and execute the models. And it kind of maps our decision modeling, it mimics our decision modeling environment extremely well. So this is pieces of the architecture. I want to just go through it very quickly. This is published online. You guys can read it. I don't want to spend any time on it. I don't want to take any more of Jacob's time. So what it looks like in an implementation is we would do decision modeling in the usual way, create our decision model, looking at processes and looking at knowledge sources. We do our decision model. We take our decision model and we generate a logical unit from our decision model. That's done for the user, so the user starts with their generated model. The user can then start actually connecting to external sources, discovering. We have a discovery tool that discovers those, supports the discovery of those external sources. And we have an ETL tool which is graphically based to allow the users to do the necessary transformations from these initial data sources to the population of the model. And then the models can be deployed under governance by IT into an execution environment. At the same time, they would deploy the decision models into the execution environment. So at this point, we really see that all of this, to about this point, is a business function. At this point, the business is working with IT, just as they work with IT when they develop the glossary, and then IT take over to the deployment. And then what this does is populate, the outputs are populated into the logical unit and allows us to do the analytics we need to do. And now our customers our clients can say that when they're looking at the history of, say, their mortgages, instead of looking at the transactions that took place and analyzing the transactions, what they can look at is the decisions that were made over the life of the mortgage, and do an analysis of those decisions rather than the analysis of those transactions. So instead of knowing what happened, they know why things happened. And this is a different paradigm. It has changed. It's changed the way business actually looks at their own business. And some of our clients are reporting some very, very interesting results from this. And that's why we are then able to use analytics and machine learning on the inputs and outputs, which is kind of the next subject of our research and development in this modeling paradigm. So that's it. Some of the features of the tool, which really you can read at your leisure, but some of the capabilities that we've seen are performance. This has enabled very substantial improvements in performance in actual field and very large implementations. A lot of people argue with me that they could do the same with standard data tools, and that's probably true. But the speed at which we're able to implement these integrations now and the speed of the integrations seem to tell their own story. So that's it. I hope I've given you some time there. Any questions, I'd be happy to take. Yes?
Can you integrate multiple heterogeneous data sources under one global view? Like for instance,
Yeah. These sources that we're using, so the adapters, if you look at these adapters include adapters to web logs. We have in the tool set the ability to actually parse free text. So yeah, we have a client who is using actually policy documents as one of their sources for their data. So yeah.
Yes, Larry, you have very intriguing title of your presentation, Last Mile.
Yes.
Can you just...
Well, this is the last mile, because for us, the problem has always been we're able to do this very quickly. We're able to do this modeling of the logic very quickly. We seem to have that solved. We seem to have a really good methodology and a good tool to help the business actually build process, decision, and then glossary. And the implementation of the process and implementation of the decision seems to be very, very quick now with the ability to generate code from the decisions, generate process, executables from the process tools. The problem is these processes require data, and and by the way, we're using this tool now to provide data to processes as well, but the integration of the decisions and the process with the data has been always, up to now, has been this long problem, has been this last mile actually. It's been the last mile that's been costing a large amount of the time and cost, and takes power out of the hands of the business. Because what the business does is they say, well, we don't have any part in the rest of this, and we just have to trust that our clients can do it. I go back 3 years to a very large project for a large financial institution with customer-facing application. We were done in 7 months, their first release. And then there were 5.5 months of struggle with the data, even though we'd given them the input requirements early on in the cycle. That 5.5 month cycle, we want to reduce down to within the same cycle of the modeling, of the decision model. And this is what this tool gives us.
So, but it's outside of the scope of traditional decision management.
The scope of traditional decision management is in our hands. We define the scope of traditional decision management. Let's redefine it.
So what is your position related to standardization? Should it be in part of standard or is tool specific?
I believe standardization is a matter of practice. I know that we want to, we believe we're God and we can influence that practice, but I think there's a lot to be said of standardizing, a lot to be done about standardizing. The opportunity is there to standardize the inputs and manage the way we look at data today, and manage how we think about data today. I think there's a lot that can be done. Certainly, from a practical point of view, this has made a huge difference. Now, how do we translate that back into some theory of standardization? I don't know. Yes.
You mentioned that you're using data parallelization, and I was wondering if you're building on top of big data products like Flink, Apache Flink or Apache Spark.
Well, we have, so we're using Cassandra to hold each of these business logical unit instances. They're stored in Cassandra as a block. Now, our connectors can look at, and we are actually connecting right now to Spark at this point, because some of the sources that we have, some of our clients have resources. But up to now, we have been storing the results of the execution, because our models produce a lot of messages, intelligent messaging in our decision models. And we've been storing those in Hadoop. And those, they generate, the quantity of messages you produce are gigantic. I mean, they really are. We're in the range of billions a year in one of our clients. And so we've been storing them in Hadoop, but it turns out that the reporting on them is, very challenging. What we're doing now is we're now storing them in this form, in this tool. Now, the problem with a logical unit instance is aggregation. Aggregation is best done in a tool like Hadoop. So we're looking at evolving how we store and we're looking at perhaps storing the output component of the decision in Hadoop and the input components in Cassandra, and connecting those in the analytics. Because the access speed into these LUIs are very, very fast in this the schema, but the problem is aggregation. Although it turns out that some of the performance in the aggregation is quite surprising as well, depending on the nature of the aggregation.
Well, yeah, just I was wondering near the end you said, people that say that other data tools could be used to kind of achieve the same thing when we have performance. You have performance that they likely wouldn't be able to get. Is that because you partially materialize the data in the business logical unit instance, or what? That depends on the policy, I guess you're seeking.
It's the business logical unit instance that makes the difference, because that's all you have to instantiate in memory at any time. So we were using, the standard tool, data stacks originally as where we started. That's where we started this journey. And we were not getting any lift from that at all. We were using it for some of the pieces here, and and some of the pieces here, but it wasn't giving us the lift that we needed. When we actually started storing those individual units as separate databases, that's when we started seeing the performance results. I mean, we are seeing very significant, the execution time for rules are very, very short. I mean, people who spend their time optimizing rule performance are crazy, because what are you you're not spending any time or money on executing those rules. You're spending time and money marshalling the data. So discovering how to marshal that data optimally, that's going to make the big difference in the real world.
Tie into that real quick. You said something about auto-discovery.
Yes.
Partially, you like to say, identify wherever it's at, and quickly from.
Well, we're using, so the tools that we're using for the discovery were built by a company that does, Sapiens specific. Sapiens has a long-standing insurance practice that built insurance solutions. And insurance solutions doing ETL is a very important part of that. And so we have been working with a company for 7 years now doing ETL on very large insurance portfolios, policy portfolios into new applications. And so they've evolved this suite of data auto discovery tools, and that's what we've integrated.
Just because this is DecisionCAMP and we had so much time around standardization in presentation, Bruce mentioned that in private discussion you told him about future field support. If you don't mind, can you elaborate about your plans?
Future field support. I think he expressed it well. So firstly, I'm a convert. I was one of those guys who wasn't crazy about the idea of field. I thought that the last thing the world needed was another expression language. Now that the world has been endowed with another expression language, I think I cannot see how we can actually complete DMN without a full implementation of expression language. The problem with expression languages is when they use the word easy or simple around the word expression language, you know that it's a march towards complexity. You start down here and you'll always end up there. That's just the reality of life, because life is complex. I think that we're faced with the reality of, if we want to implement DMN, we're going to have to implement field. And if we implement field, then field 3.0 is the solution. I have a queasy feeling about the business friendliness of DMN. I just have a queasy feeling about it. And I think that it doesn't make that any easier at all. The reality is you have to have it. I think that the vendors are going to have to work very hard to hide the complexity. that's what we're thinking about. And, I think that's what we have to solve.